All right. So, nice to see so many students up and ready to go. And let's jump into it. So, we left off with this Pokemon example, and I actually wrote my former student an email after class let out, and I said, listen, you know, you might not remember doing this example, but I still show it in class after all this time because it's been 10 years. And the funny thing about somebody doing a PhD in computer science but with a specialization really in artificial intelligence, oh really, International Programmers Day? That's cool. I didn't know that. Huh. Yeah, happy Programmers Day to everybody. That's right. Everyone in the class. So the student remembered exactly what he wrote, why he wrote it, what we were talking about. Like, good morning. He just had like this excellent memory, and he said, "Oh, that's great. You show it." He said he's honored. So it's just kind of funny how like something you may do that may seem like a throwaway, like, oh, I'm just gonna keep track of what Pokemon are doing. It really shows if you do something like this in a programming class like COP 2800. I mean, you're pretty good if you're doing. I mean, you're really good if you're doing this. And the fact that he did it just because he wanted to like think about it a little more and just write any code, I think that he's really got some interesting projects going on in his life. Yeah, the Pokemon example, it's a lot of fun, and you should definitely read through it and think about it. Like, read through what he did. It's a lot of fun. Especially if you like Pokemon. So if you actually care about these things, it'll mean even more. But if you know, you just want to learn more about object-oriented programming, it's a good idea to read through it too. So the overall view is there are abilities. You have an interface attackable, where you can either attack or have a special attack. And then your Pokemon is going to have to implement attackable. So it's going to deal with abilities and attacks and special attacks. And then here is where you're going to have your actual competitions with Bubble Beams, Fire Breath, Sleep Slash. And then there you have your special abilities. And let's see, Marcos writes, someone from my AP Computer Science class did a Pokemon game with the GUI and the health bar. Oh wow, yeah, that's great. That's really good. Sounds like an exciting end of the class final project for here, but the student did a good job. So anyways, we can close this down, but I just wanted to say that former student wrote me back, and he's really finishing up his education because the PhD is a terminal degree. That's the end of your possible degrees. So, okay, now let's take a look at a bank account. And I'm hoping today that I don't talk the entire time, that you guys can do some examples too. And then you'll send me your example, DM me your example. So you'll have like a more active day instead of just listening. Okay. So here we have public class bank account extends object. So you don't have to explicitly put extends object, but that's also legal, right? That's legal to explicitly extend object. And now we're saying that the bank account is going to have some protected data. Protected data would be data that's visible in the child classes. So protected data, like we see here, this account holder, is visible in the child classes. And another way to say child classes is to say subclasses. Child class equals subclass. Private data has to be accessed through getters, setters, constructors. Okay, private data can only be accessed outside the class with public getters and setters. And then this is our constructor here. You should probably remember the term constructor. That has the same name as the class. The constructor has the same name as the class. The constructor has no return type. And the constructor can have multiple parameters sent in. So here we see we're sending in the account holder, and we're sending in the balance. And then just under main, we're actually making a bank account, just to show we can make a bank account. Then we go to savings account, and we see public class savings account extends bank account. So remember the is-a relationship. A savings account is a bank account. But what specifically does a savings account get you? So somebody who already has a bank account in here, maybe you might have a savings account. Just sort of think that through. What does a savings account actually give you that the bank account doesn't give you? Well, I sort of have the answer right here. So basically an interest rate. Okay, you're going to get an interest rate. I'll just sort of answer the question. You get an interest rate, which means that they're going to pay you for keeping your money in the savings account. It's really not much, right? Even if you have a lot of money, it's pretty low. Okay, so now we look here at the constructor for the savings account, and we see the keyword super. We see the keyword super. So super means accessing the superclass or parent class. So the parent of the savings account is the bank account. So when we send in the string and the double, we can see back at our bank account, oh wow, look at this, they have string and double. Okay? String and double. So the order matters. The order matters. Alright, so then we see in our main method, our driver method, that we can make a savings account and just practice getting the balance. And this is just a very common example that probably students all over the country, all over the world right now are thinking about a bank account, and they have the class bank account, class savings account. It's just like super common example. All right, and we could probably look up more in-depth examples if we went here to GitHub. Let's find some good bank account Java examples. Bank account Java. All right, so here we have Columbus. Is this the Miami Columbus? Let's see. It might be, who knows. So let's see what they do for bank accounts. So they have bank account Java. Oh, they really didn't do anything. Oh, okay, so they just gave the exact instructions. I mean, this is exactly what we're talking about here with constructor and get balance. Ooh, multi-threaded. This one will be a little more complex. Yes. Threads are an advanced Java topic, so it won't be bad to look at them, but it's something we won't touch. So we need locks because we have a shared mutable variable, available funds. With no locks, this could happen. Account source has $100 in available funds, wants to transfer to account destination 30. Account source has $100 available funds, wants to transfer to account destination 80. Checks to see if the source is greater than the amount, condition is true, then for some reason it's false. Available funds are still at 100, so the condition is true, and it transfers the money, so we're talking about to the 80. So yeah, if you do both the 80 and the 30, you're definitely not going to have enough money. So if we look here at the account, we say, look, it implements runnable. So if you want to work with threads, one way of doing it is to implement runnable. So this is a more advanced Java topic, but it's fun sometimes just to look at like a bank account that we're talking about, but you know, for a 2,000, a 3,000 level or 4,000 level Java class, right? And so they're using generics for the bank account because they don't care whether it's going to be a you know, savings account, bank account. And then it's kind of fun. We can see the different people. Oh, this student does not have a public GitHub because you can't click on it. So since we're here at GitHub, let me go here to my repositories, and let me go here to overview. Actually, let's go to GitHub Classroom. GitHub Classroom. Alright, and then let's go here to Monday, Wednesday. Alright. Let's see. Alright, is Jorge here right now? Is George here? Fuerte?
Yeah, I'm here.
Okay, great. So I see you've gotten two. Oh, you have a lot of things that you've done on GitHub. Okay, 137 contributions. Wow, this is excellent. Do you want to say a few words about uh, what you think about GitHub and what you think about Git?
I mean, sure. So far, GitHub's been really cool to like manage my projects. I've been trying to learn Git, but I mostly use their GUI, GitHub Desktop.
Frankly, me too. And that's something that I've always like. Yeah, yeah, me too. I'm in the exact same position. Um, the 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 desktop is pretty good. Like it handles it handles pretty much all you're going to need to do for this class. I know for really like complex projects, you've got there's definitely benefits to learning the command line. I I'm not really a command line expert at Git at all, but let's see here. So a lot of other people have already like made their accounts and set things up. I think part of this first assignment is making some commits. So I think some people are still working on it. But right now we've got 19 students who have signed in to Git and GitHub Fundamentals. So that's good. So before we move on to more assignments on here, right? Like I'd like everyone before next class to log into this and finish this Git and GitHub fundamentals. So make sure to log in to the GitHub classroom and complete these exercises. So if we were to copy this assignment here, just post it here again. But it's also posted on the class canvas, so you have a few different ways of getting there. So just make sure to spend some time going through the assignments, through the assignment on Git and GitHub fundamentals. Okay. And then once everything is finished, I get an email, and it adds everything you added to my GitHub, and I can see it and get an email. All right, great. So let's close that. Let's close that. And although it would be fun to look through some of those projects, it looks like there's a lot of web stuff, and it might be like beyond this class. So we can close there. We can go back here to Module 4. And we are on a Publix example. Okay? All right. So for our Publix example, we have class food implements quality checker. Well, what's quality checker? Well, quality checker is an interface. An interface is a list of methods that other classes that implement the interface must deal with. So for our Publix example, things are going to be all about food, right? So we start with this class food and the quality checker, and we're saying that food has a name, if it's perishable, if it's edible, the price, the weight, then we have our constructor. Now if we have the same name for the parameter as we do for the field, then we have to use this. This indicates the field, and that's going to go on the left-hand side. Okay, so we'll just put here, this is the constructor using this. And now we have some getters. Okay, the getters are going to return some data about this object. So is perishable, it's going to return true or false. Is still edible, and then Well, really our toString is not a getter so much as it is sort of part of every object. Every object has a toString. And really in the Java documentation they recommend that you override your toString if you're making a new object. So now we get into the inheritance example of the project. Class cereal extends food. Alright, well cereal is a food, that's the relationship, is a. So we have all the things that we have for the food, like we have name is perishable, is edible, the price, the weight, and then we're also adding in a UPC because, you know, a grapefruit wouldn't have a UPC, but a cereal, a box of cereal would have that. And then grams of sugar because, you know, most cereals have a lot of sugar added, and that just helps with the taste. So we can go ahead here and copy this cereal constructor just to keep in the class chat. Alright. And then under the app we add in our scanner. We can make the different cereals and then show the different cereals with the print statement at the end. Okay? Alright. So, questions about object-oriented programming right now. Could be just generic questions about any of these different things. Alright, well, let's do an example. Oh, someone is typing a question. Today's a bit quieter than usual. Well, that's okay. People are just thinking, taking it all in. Oh, okay, what does OOP again? So O stands for object, O stands for oriented, and then P stands for programming. So object-oriented programming, that's where you design the class, design the interface, you know, design the subclass, and then you create objects from your classes to solve the problem. So like in our Publix example, we could have multiple arrays of the prices and if something is perishable, things like that. But a more acceptable way of doing things, well not a more acceptable, just a, we'll just say common way of doing things is to just make the class and then make the object and, you know, keep track of the data that way. Alright, so let's do an example now so you guys can do some coding. And let's see, since we saw a Columbus High School example and some people were talking about AP Computer Science, let's do like a high school example. So you are writing a program to keep track of students in a high school. So for class student, we'll make it kind of specifically about computer science. No, we'll make a generic class student. Class student is going to have the student name. Class student is going to have student gender, and we'll do age in, we'll do year in school. And then that'll be good for class student. And then you'll have class computer science student, where it will be everything in student, but plus you're going to be adding in the favorite programming language, and oops, 1 second. Okay, so we have the favorite programming language, and we'll also do whether or not the student has passed any certification. So it'll be like a true-false. Okay? So we won't do an interface for this. We'll just do the subclass and the parent class. So which is the parent class and which is the child class in this example? Yes, student is parent. Good, good. And then that would mean that, very good, the child is the computer science student. Good, good. So that would help you think about the extends. So once you do this, send me your 2 classes as part of the Replit, right? I'd like everybody to use Replit for this and send it over to me. And what really makes this nice is when I ask students to do these different projects through the semester, you know, then later at the end when I look at our DMs back and forth, our DMs will be filled with these projects. And then some students never send me a DM because they're never doing these things in class. So right now it's just another way to judge effort and what you're doing. But this is really how you're going to get better at programming. And after we do that, then we can add like a set of scanners to read in names. But right now, just make the 2 classes and then send it over to me. Okay? So I'll just mute myself and then respond through DMs just so I'm not talking so much. All right, so other questions about this? Let's see, I see Pedro typing. Pedro says, are we doing everything in student or the student name, gender, and year? Okay, so inside of student, you're going to have a name, the gender, and the year in school. So the student will be the bigger concept, and then within there, you can use all these different examples here on the class website. Like, you can just have the car example open. So if you look at class car, you say, okay, well, class car is like the student in this example. So public class student, and then inside of this we have brand, miles per hour, max miles per hour, and horsepower. That's where you're going to have name, gender, and you're in school. Does that make sense? Okay, I'm going to mute and then you guys can send it over to me.